Hello, everyone. Thank you for joining. My name is Jamal Arif, and I'm part of the Oracle Cloud Infrastructure team. Today, I'm going to talk about connectivity options within OCI, and specifically on the VPN Connect, which is an IPSec based connectivity service. Our safe harbor statement. So, main objective of this video is to go over some of the design scenarios or the design considerations that you need to make before you are selecting which connectivity option from OCI. And then we'll take a deep dive into the VPN Connect and also see a demo in by the end. So let's quickly recap what are the different connectivity options when you have workloads running within your virtual cloud network. So the first option is that if you have your workloads within a virtual cloud network in OCI, you can connect to those over the public internet. You can attach reserved public IPs or ephemeral public IPs to your workloads and then directly access those over a public internet. Of course, there are some necessary components that you need to have within your virtual cloud network, like internet gateway, an opening ports of firewall, and security list to actually allow that connectivity. The second option is using the IPSec protocol to have a secure, private, and encrypted method. There are two main options using the IPSec VPN. You can either use the managed VPN service by Oracle, and this is something that we are going to discuss today in the session. The second option is just running a software VPN on a OCI compute instance. So there are a bunch of VPN open sourced softwares that are available, and you can run any one of those on top of an OCI compute instance. That's not a managed service, but yes, you are managing the VPN yourself. The third option is using the Fast Connect service. So the Fast Connect service gives you a private, dedicated connection, and with Fast Connect, there is a consistent network experience, and you can have port speeds of 1 gig or 10 gig or increments of 1 or 10 gig as well. There is also an SLA associated with the Fast Connect service. So we went through a number of different options of connectivity with Oracle Cloud Infrastructure. Now let's talk about what are some of the considerations that you should take when you are designing your networking infrastructure. And based on those considerations, you can choose that what makes sense for your design. So for the first question that you should ask yourself is that what kind of bandwidth or throughput your application require, because that would help you decide that whether you should choose either, for instance, a VPN connection or you need a dedicated private fast connect connection. Secondly, is your application latency? Does latency matter? Are you okay with different latency numbers going throughout the day, or you need a specific latency for your application? What is your plan around redundancy? Now, when you design your networking infrastructure, it is definitely recommended by Oracle that you have redundancy in your networking infrastructure, not only on the virtual cloud network part, but also on the connectivity part of your infrastructure design. That if you have a single connectivity options within OCI, then that means that becomes a single point of failure. So you should avoid and plan your redundancy on the connectivity options as well. And as we go through this session and a couple of other sessions on Fast Connect as well, we'll discuss about some of the redundancy that is inbuilt within the service and how you can design your networking infrastructure that it's redundant and you are avoiding the single point of failure. Moving on, what's the security requirement from your application perspective? Do you need a private dedicated connection? Do you need an encrypted connection? Or you're okay with just a public connection over the internet? And then how do you see your services or application growing? Because if you need the ability to dynamically scale up your application, your connectivity option with OCI, then you need to design your infrastructure right from the start in a way which helps you dynamically scale up or down your bandwidth needs accordingly. So these are some of the key considerations that you should take when you are designing your networking infrastructure. So now that we have looked into the different models of connectivity options and also taken a look at some of the considerations that you need to make before you design your networking infrastructure, now let's talk about IPSec VPN on OCI. So IPSec VPN is a managed VPN service which securely connects your on-premise data center to the Oracle Cloud Infrastructure Virtual Cloud Network through an IPSec VPN connection. The IPsec itself, you know that it's a protocol suite that encrypts the entire IP traffic before the packets are transferred from the source to destination. So it makes sure that your remote connectivity is secure and encrypted. Normally, you'll see that with IPsec VPN, the bandwidth is around 250 megabits per second, but your mileage can vary depending upon your location and the general internet congestion at that time. The service itself is offered for free, so there's no VPN service charges for the VPN service. Normally, we have seen that mostly the customers would start with a proof of concept, and you'll use the IPsec VPN for their connectivity between their on-premise and the Oracle Cloud Infrastructure Virtual Cloud Network. And then as they move into production workloads where they need much more dedicated bandwidth or dedicated latency numbers, then they can move into other option of fast connect. And there within fast connect that there are different options based upon whatever your use case is. And as we go through in the next design, you'll see more on the redundancy. But whenever you create a IPsec VPN connection on OCI, we create multiple redundant tunnels on OCI headend just to provide redundancy. These tunnels are physically and logically isolated. I'll go into a bit more detail on this in the next couple of slides. So now that we have gone through the basics of IPsec VPN, let's go and talk about some of the concepts or some of the key objects that are created when you are creating the IPsec VPN connection. The first is a dynamic routing gateway. So as you must have seen, read and gone through it in the previous lesson 100 as well, a dynamic routing gateway is a virtual router, which is basically a gateway into your virtual cloud network from your on-premises network. So when you are using an IPsec VPN to connect to your on-premise network and the VCN, the traffic actually goes through the dynamic routing gateway. From a networking engineering perspective, you can think of DRG as the VPN head end on the OCI side. Once you have created the dynamic routing gateway, you also attach that dynamic routing gateway to your virtual cloud network, either through the console or the API. And you also add one or more route rules that route the traffic from your VCN to the dynamic routing gateway. Without this attachment and the route rules, the traffic will not flow between your VCN and your dynamic routing gateway and at the end on your on-premises network. The second key object is the customer premises equipment. So at your end of the IPsec VPN connection is the actual router in your on-premise network. That is what we call as a customer premises equipment within the OCI VPN concept. When setting up your VPN, you have to create a virtual representation of that router. We call it as a CPE device. Basically, it's a CPE object. And when you're creating the CPE object, it contains some basic information. You provide the basic information like just any name and then the public IP address of your CPE object, which is your actual router on your end. Once you have created the CPE object and you have the dynamic routing gateway also attached and created in your OCI console, from there onwards, you can go ahead and create an IPsec VPN connection between your dynamic routing gateway and your own actual router, which is a CPE. And when you create a IPsec tunnel, we create multiple redundant IPsec tunnels, which are logically and physically isolated. And each tunnel has information which is required when you set up when you configure your on-premises router. So it has an IP address and a secret key information. Once you have created the IPsec connection, you can configure the type of routing for your IPsec tunnels. You can have different routing for each tunnel as part of your IPsec connection. You can choose the BGP dynamic routing, which basically uses the BGP dynamic protocol to learn the routes dynamically. From a DRG perspective, we would advertise routes of the VCN the DRG is attached to, the VCN subnets. On the static route, you can also choose a static route connection. And in case of static route, you provide the routes that you want to DRG to send the traffic towards. And similarly, you have to use the same static. You'll have to add those static routes on your CPE device as well. So that's all from this video. Thank you for joining.